Hi students, it's Dr. Marks and our topic for today is data sets. Now we've been talking about the process of data collection in earlier lectures, and at this point we've introduced this idea of variables. We've talked about qualitative variables and quantitative variables. We've talked about subcategories and how to code things that are qualitative. So in general, we've been hinting at the idea of compiling data sets because after all, that's what variables are used for. They're parts of data sets, and we use that for our data analysis. So when we talk about data sets, we specifically mean a collection of related sets of information that is composed of separate elements. So those separate elements could be variables, but can be manipulated as a unit by a computer. So a collection of related sets of information that is composed of separate elements but can be manipulated as a unit by a computer. Now, why do we even collect data and create data sets? Well, lots of different reasons. Well, first, we need to generate information. So we analyze data simply to convert it to information. For example, I might be looking at Longwood students and I want to get a sense of, what is the mean level of performance in terms of GPA? So I can get that data, put it in a data set, and convert it to information. But that information also gives us knowledge, so we can interpret that information to gain knowledge. Okay, so is that mean GPA reasonably high? Is it reasonably low? Is it something we are content with? Is it something that we're unhappy with? And from that, we can make some insights. So we can make connections in the information to gain insight. And we might be saying, okay, we're looking at this data and it turns out that it's a little lower than we expected. Maybe it's below the average GPA of our peer institutions, and so this gives me some insights. Maybe we need to focus a little bit more on working on students that fall in the bottom tail to help them boost GPAs. And from this insight, we can get wisdom. We attain the wisdom to appreciate why the insights are important. All right, what happens when my students have low GPAs? Are they at a risk for leaving the university? Of course, we're concerned about retention. When we lose a lot of students, we lose a lot of money, and that can be problematic for our budgets. And then we can think about the impact. We can use the insights to make an impact. All right, based on what I have learned in terms of this information and the insight that I have, now that I've made some connections, I can use that insight to make an impact by thinking about how can I affect retention at the university so that I can help the bottom line, that we don't have as many students leaving the university, and that's going to be incredibly impactful if I can make that happen in a way without, of course, lowering standards or asking professors to give away better grades when they're not deserved. So lots of reasons we collect data and create data sets. There's a lot of information we can glean from them, and then we can parlay that into knowledge and insight, wisdom, and finally impact. Now, on its own, data and data sets are useless, right? Just having data and not having the ability to do anything with data and these data sets doesn't really benefit us, right? It's the information that we gain from the data that makes it useful. And that's why we want to better learn how to glean good information from data. And as we've talked about, good data collection strategies are very important, but so are the good analytical approaches. We want to collect good data, but if I have great data, but I can't do anything with it, or I'm not using valid techniques, or I'm getting information from my data, but I'm interpreting it wrong, well, those are bad analytical approaches. And so that data, while it might be fantastic data, doesn't really do anything for me. Now, there's many ways to collect data. We could be administering surveys or questionnaires, and I know a lot of you have participated in surveys or questionnaires that have been delivered to you. It could be on your job. It could be something that was delivered by email. Maybe you're a customer at a store and they want to reach out to learn more about satisfaction. But Interviews are also a way to collect data. And I'm not necessarily talking about I'm interviewing for a job, but sometimes we might have interviews with consumers of our products. We might be interviewing people to learn more about maybe an untapped market need, get a sense of would a product be valuable in the marketplace? What are people's willingness to pay for that? Direct observation is a manner for collecting data. So in the sciences, obviously a lot of what they do is direct observation. I take students into the Amazon jungle with my partner for that program who is a biologist, and we're studying conservation biology, and they're doing direct observation by doing field work. So collecting data. But businesses can also do direct observation, right? It's not unique just to science students running around in the Amazon jungle, right? So we might be looking at behavior of clients or customers by observing them, and how long do they spend in a store? How many times do they pick up a product and put it back? Do they pay attention to products that are on lower shelves, or are they only looking mainly at mid-level, eye-level in terms of placement of products? So there's lots of things that we can glean from direct observation. Some of you may have participated in a focus group. We might gather a group of people together to ask them very specific questions to gain their responses. And this is a little bit different than a survey, because surveys sometimes don't ask a ton of open-ended questions, right? But in a focus group, we can throw out a question and we can ask for people's feedback related to a specific idea or a thought. And so it's a way to get better exchange of information without limiting ourselves to what people are willing to type into a survey. Getting information from existing documents or records is also a form of data collection. So if I want to get stuff on historical prices of gasoline, for example, I can find that data in various places. So existing documents or records. Laboratories and experiments. There are also methods for getting data. Now, laboratory experiments we tend to think of as being science related, but actually economists conduct a lot of experiments. We have a colleague at our university who is an expert in economics experiments, and we're trying to get a sense of people's behavior when they're faced with various scenarios in an economic laboratory setting. Regardless of what manner we're talking about collecting data, we do need to distinguish between primary and secondary sources of data. So let's move on to talk about those things. When we talk about primary data, we're talking about real-time data that's collected by researchers directly from the main source. So real-time data collected by researchers directly from the main source. And so what we're talking about is researchers that are collecting new information. And because it's new information, it's potentially more accurate or more up to date. So maybe this is going to be a little bit more, cutting edge information that's coming in. But collection of primary data can be very costly to collect, depending on what kind of manner you're trying to collect it in. So let's think about surveying clients at the end of their customer experience. Do we agree that that would be a primary source of data? We're collecting real-time data from clients and getting their feedback. But to do that, we have to have people who are going to be, interviewing all of those individuals, or hoping that surveys are being completed. So they could be a face-to-face survey. It could be something delivered online, and hopefully those clients will complete it, but they don't always. We could be capturing data at checkout stands at stores. For example, I have a colleague who does research on donation behavior at checkout stands. So think about when you've been at the grocery store and you've been asked, do you want to donate $1 or do you want to round up for some purpose? Well, can't data be collected at that point right there? And she does that. When she does that, she's collecting primary data. We also know that there are experiments that are used to generate data. So imagine experiments related to health outcomes when they're testing a new drug. That is clearly primary data, and you can imagine it's incredibly expensive to collect that kind of data. But if you have a new drug and you want to bring it to market, you have to go through the very lengthy approval process with the FDA, and that's going to require lots of experimentation and data collection as you try to get approval for this drug. We've talked about focus groups conducted by companies. So a marketing firm could be hired to conduct a focus group with potential clients or customers to get feedback for some entity. And that, of course, would be primary data. But also letters and diaries from historical figures. We tend to not remember that that's primary data as well. So if we're collecting information right from those documents from historical figures, we are working with primary data. One type of primary data that we wouldn't have talked about when I was young is social media. Social media is monitored, so we can do a lot of social media monitoring and collect real-time information. For example, how much are people talking about your brand or your company on social media? And when there is discourse on social media, is it positive? Is it negative? You're collecting data in real time, right from the source. How are our competitors portraying themselves on social media? That might be good data for us to collect because, again, we need to be competitive, and social media is now clearly a platform where competition is taking place. So tracking what our competitors are doing and how they're portraying themselves. What can I glean about my competitors' strategies from social media? Is there anything that my competitors are revealing to me when I look at their posts on social media? And is the market through social media communicating an unmet need? Maybe they're signaling that there's some market, some demand that can be tapped into that's not being met by competition. So we understand primary data. Secondary data, on the other end, is data that's already collected through primary sources, and it's been made available for researchers to use in their own investigations. So data that's already collected through primary sources, but it's being made available for researchers to use. So secondary data. There are tons of government statistics. The Census Bureau has data, the Economic Report of the President. You can find lots of government statistics. You can go to the EPA, you can probably go to the FDA, you can go to the Social Security Administration, and they keep all kinds of statistics. And those are publicly available, and they're available to be used. But there's also great sources of data from global organizations like the World Bank and the IMF, the International Monetary Fund, and as economists, we use that kind of data all the time. But again, they've done the data collection, so they were responsible for the primary data. When we're using it, it's secondary data. We could look at industry associations data. We've got oil industries and banking and real estate, and they keep all kinds of data, a lot of which is publicly accessible. Now, not necessarily everything. There's some things that are proprietary, and they sell those data sets, but it's still secondary data. There are trade publications that are available, and some industries will subscribe to these trade publications, and that would be a continual source of data, but again, secondary. Company websites offer a source of secondary data as well. Finally, marketing research reports. These marketing research reports offer forms of data. So we understand primary data and we understand secondary data. Often, our investigation requires use of a data set. Some of you might be responsible for putting data sets together. Other people might have data sets compiled by different departments and then given to them for analysis. But either way, data is important for a lot of our different business decisions. Turns out there are 4 different types of data sets. The kind of data you need depends on the question that you're trying to answer. So the four kinds of data sets we're going to talk about are cross-sectional, time series, panel, and pooled. And we're going to go through each one of these individually, and I'm going to give you lots of examples so that you can understand. Let's start with cross-sectional. When we look at a cross-sectional data set, we're observing many subjects at the same point in time. That's important. So many subjects, not just one, and they're all at the same point in time. And when we're working with cross-sectional data, there's no time dimension. So in my data set, I don't have year 1, year 2, year 3. I don't have March, April, May, because those are time dimensions. So in cross-sectional data, there's no time dimension. So the data in my data set goes across subjects. So could be person 1, 2, 3, company 1, 2, 3, but it doesn't grow across time. Now remember, as we've talked about before, subjects in a data set could be people, they could be countries, they could be states, businesses, they could be regions within a business. Again, we want to get in the habit of asking ourselves, for this data set, what constitutes an entity? What is an observation? Let's look at some examples of cross-sectional data. Let's say that I have 2020 sales data for 20 regions in a firm. So we have one company, they have 20 different sales regions, and my data is for 2020. Do we agree that we have multiple entities? 20 regions. Even though it's one firm, it's 20 regions. So I'm going to have 20 observations, and all of my observations are for 2020. There's no time dimension. So this would be an example of cross-sectional data. We're going across entities, regions, but not across time. What if we're looking at new hires across states for Apple during the month of March? All right. So again, don't be confused by just Apple being one company. We've got across states. So I've got Apple in Virginia, Apple in North Carolina, Apple in Kentucky, Apple in Maryland. You get the idea. But it's just one period of time. What does March look like? So that would also be cross-sectional data. What if I have 2021 sales volume for your product that's sold by your company across all Kentucky grocery stores? All right, 2021 sales volume just for this 1 year. So there's no time dimension, but I have a whole lot of different entities. I've got grocery store number 1 in Kentucky, grocery store number 2 in Kentucky, grocery store number 3 in Kentucky, but they're all for 2021. So I have multiple entities in the same period of time, cross-sectional. 2017 standardized test scores for 5th grade students in Virginia's schools. All right, so I have a whole bunch of 5th graders, right? Probably have thousands of 5th graders. So each one of those 5th graders is an entity, right? Is an observation. So I have standardized test scores for Bob, standardized test scores for Sue, standardized test scores for Mary, and all those students, but it's just for 2017. So clearly cross-sectional data. I could be looking at 2020 poverty rates for counties in Texas. An entity would be a county in Texas, and all of the data is for 2020. Or 2019 obesity rates of students by colleges in the United States. 2019, it's just one point in time. I've got a bunch of different entities. Remember, it's not students, it's obesity rates by college. So an entity here would be a college. Or finally, the total COVID cases by state on January 1. So 2021, January 1, that's my point in time. And I've got data for every state. So that's going to give me cross-sectional data. So hopefully you understand all of these examples and why they're cross-sectional. But I want you to think about what this type of data can and cannot tell you. So when you're working with cross-sectional data, you have multiple entities. So you can look between those entities, right? You've got different states, Kentucky and Maryland and Virginia and North Carolina, but they're all at the same point in time. So what we can't learn is how things change over time. because cross-sectional data, remember, has no time dimension. All right, let's move on to our second type of data, which is time series data. Time series data is observing a variable or variables over time, hence the name time series. So time series, we're looking over time. And time could be lots of different denominations, right? It could be annual data, it could be quarterly data, it could be monthly data, weekly data, daily data. Again, it's whatever your question suggests you need to have to answer successfully. But when we're working with time series data, there's no cross-sectional dimension. So we don't have multiple entities. So remember, with cross-sectional data, if I had state data, I had obesity rates, let's say, for this college and that college, or I might have something to do with states. So what is the smoking rate, proportion of the population that smokes in Virginia and in North Carolina and in Maryland. But here, there's no cross-sectional dimension. So we're not going across multiple subjects here, only across time. So I have to have a single subject that I'm looking at over time. So let's look at some examples of time series data. All right, Apple stock prices for a period of 25 years. Apple stock, that's one entity. I'm not comparing Apple and IBM and Dell and all those other computer companies, just Apple. And we're tracking it over time for 25 years. Or maybe we're looking at the monthly economic growth rates for the United States for the last 4 decades. I'm not comparing the USA to China or any other country. I'm simply looking at USA over time and asking, how do they look for the last 4 decades? Maybe I'm interested in annual Dell computer sales volume since 2010. Well, I can track Dell computer sales over time, but what I can't do is compare Dell to Apple, for example. So again, think about what this type of data can and cannot tell us. It allows us to track one entity over time, but it doesn't allow us to compare between entities. Now, what if we actually want to compare across both dimensions, both time and subjects? Well, if we want to do that, then we need to combine the two data set types that we've already discussed, right? Cross-sectional and time series. So to do that, we need a more sophisticated type of data set. So we need either panel data or pooled data. Now, they're not the same thing, and they have a slight distinction that we need to make very clear. Let's start by talking about panel data, which is sometimes also called longitudinal data. When we're talking about panel data, we have a set of subjects and they're tracked over time. So we've combined cross-sectional data, right? Set of subjects is the cross-sectional element, but tracking over time, that's the time series element. So we basically have cross-sectional time series data. So it's the same subjects from year to year, and that's an important distinction with panel data. It's the same exact subjects, but year to year to year. The subjects aren't changing each year. And we're tracking that set of subjects for the same time period every year. So that gives us N subjects over T periods of time. If I multiply those together, N subjects multiplied by T years, or whatever periods of time, months, quarters, I get a data set that's pretty large, right? N multiplied by T, that's going to be the number of observations. And so a panel data set can be quite sizable. And that's why panel data is considered to be the gold standard. It's really, really rich. This is the best we can do. The same exact subjects tracked over the same exact period of time really gives us a lot of ability when it comes time to analyze. Let's look at some examples of panel data, again, also called longitudinal data. So let's say we're looking at poverty rates for 100 counties in Texas, and we're tracking it for 20 years. we have a cross-sectional element, right? 100 counties, and those are the same counties for every year in the data set. 20 years, each county is tracked for the same identical 20-year period. GDP growth rates for 100 countries tracked from 2000 to 2020. So similar example, I've got a cross-sectional element with 100 countries. It's got to be the same countries from year to year to year, and I'm tracking them over the same 20-year period. Maybe I'm looking at COVID cases per day by country between 2020 and 2021. All right, so I've got countries. I've got to have the same countries, and I'm looking at it daily for this period between 2020 and 2021. So again, this is panel data because it requires us to have the same exact countries over the same time period. We have high school students' test scores tracked over grades 9, 10, 11, and 12. So again, this is panel data if it's the same high school students and we're following them from 9th grade to 10th grade to 11th grade to 12th grade. So our panel is going to be a square in all of these examples, right? We have the same subjects multiplied by the same periods. Now, as I said, and you're going to see in a second, when we talk about pooled data, one key distinction, the thing that makes panel data so rich, is that it's the same subjects. So it's not a random sample of 100 counties each year. It's not a random sample of countries. We're not changing students each year when we collect the data. Same subjects. So think of it as tracking. We're literally tracking those same subjects. Finally, we have pooled data, which is also sometimes called pooled cross-sectional data. Now, when we talk about pooled data, we're combining cross-sectional data sets for more than one period. If we're combining cross-sectional data sets, then we're not talking about the same set of subjects. And this is where pooled data is different from panel data. I'm not tracking the same set of subjects. So this is not the same student that I'm following over 4 years. In fact, it can be a different set of subjects each period. Now there could be some overlap, but in year 1, I have a sample of subjects. In year 2, I have a sample of subjects. In year 3, I have subjects. They could be overlapped. They don't have to be overlapped, but it's not the same set of subjects where I keep every one of them in the sample from year to year or period to period. Now, this means we don't have longitudinal data, because longitudinal data, that term, longitudinal data, is what we use when we talk about kind of tracking an entity. So I don't have the same counties where I'm looking at the same exact counties over a 20-year period trying to look at poverty rates. I know this is a little confusing, so let's look at some examples of pooled data, and I think that will drive the point home. Let's say we're looking at standardized test scores for 5th grade students in Virginia from years 2010 to 2012. All right. So let's think about just 5th grade students. That's all I want. Do you agree with me that it can't be the same kids from year to year to year, because they wouldn't still be in 5th grade, right? So I want 5th grade students in 2010, I want 5th grade students in 2011, and 5th grade students in 2012. So unless you really are a bad student and you're in 5th grade 3 times, you're not in the data set every single year. So those kids in year 2010 are not the same as kids in year 2011 and are not the same kids as years 2012, with the exception of somebody held back. So what we're doing here, guys, is we're combining different samples of 5th graders taken at different times. I have a sample of 5th graders for 2010, a sample of 5th graders for 2011, and a sample for 2012. Here's another example. Let's say we're interested in real estate and we want to see sales prices for houses sold each year between 1990 and 2000. So in this case, an observation is a house, and we're capturing sales price and anything else we want. Do you agree that the houses sold in 1990s not the same ones in 1991? Now, could there be a house or two that was sold in 1990 and again in 1991? Sure, could be. But what we're saying is it's not the same set of houses. So each year we have a different sample. I have the sample of houses from 1990, the sample from 1991, 1992, 1993, and while a house could show up more than once, it's certainly not going to be all of the same houses. Finally, let's look at ice cream flavors selections for your customers at a local Ben & Jerry's. And we're going to track that for 100 days. So this is going to be our primary data collection. We want to find out what is it that people are buying and maybe how many different flavors do they test, etc. So we go to the Ben & Jerry's, we record this data for 100 days. Do you agree? This isn't panel because I'm not tracking the same customers every day. That would require the same exact people to show up every single day, and that's not going to be the case. So each day the customers are not the same set of customers. Now, could somebody show up more than once? Sure. Maybe somebody comes every Friday for ice cream, and they're going to show up in the data set more than once. But the key thing is that each day we have a set of customers and they're not the same. So we're not literally tracking the same customers over time. So panel data versus pooled data, the key distinction is it the same set of observations, or rather of subjects, that we're tracking over time? If it's the same exact set of subjects, we're looking at panel data. If it is a different set for each period, it's pooled data. So, as we said, our different types of data sets: cross-sectional, time series, panel, and pooled. So there are questions that you should think about when you're trying to determine what kind of data you're working with. Question number one is, what constitutes an observation? Think about your data set. Put your eyes on your data set, or try to visualize, if it's just a question, maybe on a quiz in your mind, what would an observation be? Number two, you need to ask yourself, is there a time dimension? Because if there's no time dimension, it can only be one thing, right? It would be cross-sectional. The third question you can ask yourself is, are the same subjects being tracked across time? If it's the same exact set of subjects, it's panel. If it's only one subject, it's time series. If it's a different set of subjects each time period, then it's pooled. So again, a little bit of practice, this is going to become very easy. Let's take a look and see if, when I give you data, you can tell me what kind of data this is. So I've given you data for 2019 different months and the number of new Kentucky Fried Chicken franchises that were opened. All right, so gang, what kind of data is this? Well, we're tracking over time, so I can rule out cross-sectional, right? But how many subjects do I have? We've got Kentucky Fried Chicken franchises. It's the only thing we're interested in. We're not looking at Kentucky Fried Chicken and Burger King and McDonald's, right? Everyone agree this is going to be time series data. Now, what about this example here? I've got data for 2019. I've got a bunch of different companies: Kentucky Fried Chicken, McDonald's, Burger King, Cookout, Panera, so on. And for each one, the number of franchises opened. So Kentucky Fried Chicken opened 89, but McDonald's opened 74, and Burger King opened 88 in 2019. Do you agree here, guys, that this is cross-sectional data set? There's no time dimension. This is just static data for 2019, a snapshot in time. But yet I have a bunch of different entities or subjects, right? They're all companies, but they're different fast food type companies. So this is cross-sectional data. Now, what if instead I add a column? So now we've got Number of new franchises opened for all the same entities, Kentucky Fried Chicken, McDonald's, Burger King, Cookout, Panera, and so on. But now, instead of 2019 data only, I have 2018 data. Do you agree now that we have both a cross-sectional element because we're going across different companies, Kentucky Fried Chicken, McDonald's, Burger King, but we also have, it's not a very deep one, but we have a time element, right? Because we have 2 different years. So, what kind of data would this be? Everyone agreed that this would be panel data. And the beauty of panel data is that I can track each company over time, but I can also make comparisons in between companies, Kentucky Fried Chicken versus McDonald's, for example. Finally, if we have standardized test scores of 5th graders, and I've got individual students, 2018 and 2019, but do you notice it's a different set of students in 2019 than 2018? I'm not literally tracking the same person because a kid's not going to be in 5th grade in both 2018 and 2019, of course, unless they failed. But nobody did here. What kind of data is this? Do you agree that it is pooled, or we might call it pooled cross-sectional, pooled data? All right, so we have now reviewed the 4 different kind of data sets, and hopefully you can look at data, or if I give you a scenario, tell me what kind of data we're working with. So let's talk about some data collection issues. What process will be used to collect data? Are we talking about focus groups? Are we looking at survey data? Or are we collecting it from a secondary source? And if it's survey data, and I'm collecting it, is my instrument well crafted? And survey development is really an important thing. And we're not going to cover survey development, but we certainly want to think about issues that could be relevant. So do I want to capture quantitative or qualitative data? Or maybe I want to capture both kinds of data. Am I able to answer my research question with the data? Well, my survey certainly needs to be designed in a manner, or my data collection process needs to be designed in a manner that will generate the data I need to answer my research question. For example, is perception of work environment similar when comparing newer employees with those that have more years with the company? So if I were to ask people about their perception of work environment, it's positive, it's negative, it's supportive, whatever I want to learn. When I compare newer employees with those that are more experienced, have more years with the company, do I get similar responses? Well, first of all, if I'm going to answer this question, it requires that the data set have both represented, right? If I only get new employees completing a survey, I'm not going to have what I need. Have I introduced any selection bias? And we've talked about this many times, so I know you're getting sick about thinking of selection bias, but it's so important. Will only disgruntled employees answer a voluntary survey, right? If I'm simply saying, please do this, it's optional, complete the survey, we know that people who are upset or mad about something or unhappy might be more likely to answer the survey. So I could have a selection bias in that people are self-selecting based on how unhappy they are. And that's going to certainly taint my data collection process. It's going to give me data that's maybe skewed in one direction and may not be accurate in terms of the conclusions I make. So again, as we've talked about, we want our sample to reflect the population that we're trying to learn about when we want to investigate. Another issue, are sample sizes sufficient to use statistical methods? We're going to talk more on this later. But if I want to be able to run statistics, I can't have a data set with 10 observations. We'll be talking about why data size matters when we get further into the class, but there are statistical methods that we can use to learn from our sample, but we can't do that with really small sample sizes. So let's wrap this up. we've talked about that data helps us gain information. We understand now that there are different kinds of data sets, and to distinguish this, you are encouraged to think about what constitutes an observation in a scenario I give you, or if I give you data to work with. So what constitutes an observation? As we collect data, we want to do so in a manner that generates a sample that represents our population, right? Ding, ding, ding. You're sick of hearing that, but that is so important to understand. And that avoids the pitfalls of selection bias, which you're really starting to get a good sense for. So we've covered a lot about data at this point. We definitely will be working with some data at points during this class. Regardless, thanks for listening. I hope you have a fantastic day. And as always, guys, reach out to me if you have any questions.